This is Man Free World. This light is off. I'm Chris Lapados Stanasiopoulos. That is an open portal to who knows where. I do need to have it closed soon. Today, we're going to be revisiting my favorite physics lady, Sabine Hoffenstetter. How did that get open here? Let's close that. And we're going to be discussing dark energy. Dark energy, the missing piece. So we're just going to listen to the first couple minutes of this thing. Go give her a like and subscribe. She's pretty cool, even though she's super autistically sciencey math focused, which I understand and I do appreciate. It does one of the things that's cool about hanging out with like yoga people and or at least at the time and hippies that I've hung out with and doing trying psychedelics, for lack of a better word, makes you aware of other things that could be going on. All right, let's listen to this.
The Dark Energy Survey has surveyed dark energy and found that our universe is unlikely to rip into pieces. I think that's good news. Let's have a look. Dark energy is the name that astrophysicists have given to a hypothetical ingredient of the universe that makes the expansion of the universe faster. So it's not that dark energy causes the expansion itself, it makes it faster. Dark energy should not be confused with dark matter, which does contribute to the expansion of the universe but doesn't make it faster. Dark energy isn't like anything we know. I'm not sure exactly why this stuff is even called dark energy, seeing that it's transparent rather than dark and is...
Okay, 74% of it is dark energy, and
isn't even energy, but well, it's certainly a catchy name. Dark energy is what determines the ultimate fate of our universe, how it'll end. Will the expansion get faster and faster? Will it slow down? Is maybe even a recollapse and a new beginning possible? It all depends on this mysterious stuff, dark energy. In astrophysics, the name dark energy isn't used for just one thing. It's a term that encompasses all kinds of different things which could cause this accelerated expansion.
Interesting. So they have a group group term for a bunch of stuff.
One of these types of dark energy is the cosmological constant, usually denoted with a capital lambda. So the cosmological constant relates to dark energy like a banana relates to fruits. It's one of many.
Fair use, by the way. Fair use.
The cosmological constant is, would you have guessed it, constant, and it's the simplest type of dark energy. But like there are other fruits besides bananas, there are other types of dark energy besides the cosmological constant. Astrophysicists characterize all stuff that fills the universe by the ratio of its pressure over its energy density. This gives a quantity that's abbreviated with W. Particles that move around fairly slowly, like you and I, for example, have zero pressure and zero W. That's astrophysics for you. If you look at your calendar tomorrow, I think you should keep in mind that you have zero pressure. Dark energy.
Okay, those are scientific terms, specifically mathematical things.
Energy in general has the odd property that while it has positive energy density, it has negative pressure. For the cosmological constant in particular, the pressure is the same as the energy density, but with the opposite sign. So you have W equals -1.
Okay, I'm gonna leave it there. You can go watch the rest of that. But what I'm getting at is something called the quantum phone. They say that they always they forget that I don't know why these physics people forget that there's no the vacuum of space is not empty. It's completely full of this thing called quantum foam.
Is an idea that emerges from the application of quantum physics to the fabric of space and time itself. You see, Einstein taught us in general relativity that space and time are not an inert backdrop. They participate in the unfolding of the cosmos. Space and time can warp and curve, and that creates the force of gravity. When you recognize that space and time are dynamic, they can change, that they're real physical entities, well, then they must be subject to the laws of quantum physics. And the key element of quantum physics that's relevant is the uncertainty principle. When applied to space and time, it says space and time are uncertain, which means they can wildly fluctuate. They can, in a sense, look like the violently boiling surface of a pot of water when you examine space and time on fantastically small scales. So the idea is if you examine space on smaller and smaller scales, not everyday scales, but tiny scales, the uncertainty gets bigger and bigger, and space and time become foam-like. They look bubbly. They look frenetic.
Well, they're actually the particles that are being generated and collapse and things like that. So you can watch the rest of that if you'd like. But that's kind of like the sort of the mainstreamy science. But what I'm talking about is this Cassini, what's it called? The Cassini Effect. What's it called? The what is this called? The Casimir Effect. I always get these mixed up. So the Casimir Effect measurement. So it's this measurement that basically shows that there is a pressure being generated from this quantum foam, and it can be it can be measured by having these two plates. You can barely see this right here. It says Casimir plates, and there's the vacuum fluctuations. There's the particles being created and destroyed billions of times, if not trillions of times per cubic centimeter. All around us all the time that we don't even notice, that we don't even see it. Okay. So, and there's this more, here's a little bit on the Casimir effect.
The Casimir force is widely viewed as a force that originates from what is called vacuum energy.
Fair use, by the way.
It is often invoked as decisive evidence that the zero-point energy of the quantum field is real, but there is an alternative way of examining the force, which could be considered far more fundamental.
Yeah, so I'll let you look at that one. But that's basically it. It's the electromagnetic foam has a pressure that if you put two plates, it'll push these plates together, sort of like how boats in a harbor will have that kind of happen. And I want to just make you aware of this thing called Simatics, which is very interesting to know about in light of the Casimir Effect and dark energy. So this is just like basically a resonator. It's got basically a speaker underneath there, and this thing as a frequency generator creates pure tones that go into the speaker that is bolted onto this plate. So this plate is bolted onto the speaker, and it's putting out pure sine wave tones. Sort of like how the sound of the universe of all that quantum fake has a hum. There's a hum to it. It's like it's not. It's or kind of like a static hum, but it's still a hum. Lycopodium powder or something like that. Like, it's just stuff that doesn't necessarily stick together and just wants to stay separate, and it's actually hydrophobic as well. So it's made from like mushroom parts of like spores of mushrooms. And they've been using it for this kind of stuff for a long time. You can see as the frequency increases, these shapes just form in the forms where the plate is, where it's vibrating. The material is pushed away, and where it's not, where there's voids, it sticks in and just kind of stays there. And these shapes are automatically produced and can be regenerated. Give them a like. I'm gonna mute the music because it's just super annoying. So you can see as it changes up frequency, they change frequency. You get these shapes. I kind of imagine these in 3D. If we just didn't have the plane, if it was like a 3D crystal, how these would exist inside the crystal as well as the 3D crystal is resonating. You can't see it because it's it's thick, but that's the kind of stuff that would happen, inside the crystal because it's happening on top of the surface. If it's, you would have the same kind of thing inside of a, crystal. If it's vibrating, you're gonna get these areas that are vibrating more, and the other ones that are not vibrating as much, and that's where the material is deposited. And it has these really organically, really kind of egg shapey patterns. There's another one right here. There's egg shape. This kind of like egg carton shape. Egg carton shape. Okay, so I want to make you aware of that. And here is some papers about the simplest lattice matching these restrictions is an egg carton network. They talk about the shape of our universe and these superclusters that are around us, and why they're shaped in this they're in this lattice pattern. They're distributed in these lattice patterns. And they're following along? No, not yet. Okay, so I just want to make sure it's like this is. Where is it? There's a good one right there. Okay, and here's that paper. It shows this latticey type of arrangement, and they say it looks like this. I just want to put this back here. This and this and this. And so what's curious about this is they haven't really thought about how the humming of the universe is putting this stuff in this arrangement and this because of just how it's the frequency it's at, and this it's pushing things out of areas and pushing things towards areas. And we already have an example of this by MOX Principle. And MOX Principle says that the gravity we have here, the inertial frame we have, exists because of the very distant objects, all the gravity, because there's so much of it and there's so many of it, and it's far away. It doesn't have a great effect, but it has a small effect. So that's where our gravity field's coming from. So we have some insights that, yes, small effects can come from faraway places, and we can also have large effects from very tiny things. Okay, that are all over the place.
Dirac's large number hypothesis, if we go back, if you put these two observations together, there is another very interesting coincidence which goes back as idea to Ernst Mach in 1883. So he had the very, very intriguing idea of relating the strength of gravity to the masses of the universe. The problem was nobody knew about the size and the mass of the universe back then because cosmology wasn't even born as a science. Okay, so we have the unfortunate situation that
I'll let you go watch the rest of that video. Fair use, by the way, and go give him also a like and subscribe. Unzucker's breaking down lots of walls of physics, but yeah. So there is a precedence for this being a thing, and I just want to make you aware of it. All right, that's about it. I'll talk to you soon.